All right. Good afternoon, boys and girls. It's me, Mr. Musselman. Miss P is on a great science adventure today, so I thought that I would stand in for Wendy's Wild Wednesdays with a wonderful program that I like to call Pumpkin Science. We're going to do all sorts of fun pumpkin demonstrations today. We're going to be learning a little bit about pumpkins from both me and some local pumpkin engineers. But before we get going, I wanted to give you an opportunity to share what you know about pumpkins. After all, pumpkins are a big part of what we find here around Burlington in the fall and all over New England. So I want to start with a conversation about the properties of a pumpkin. The word properties is a sciencey word for the words that we use to describe pumpkins. So I want you to think about some words that you would use to describe pumpkins. Go ahead, think and share with me right now, right through your screen. Oh, wow. Those are some wonderful ideas about how we might describe pumpkins. When we think about pumpkins, we've got lots of different ways to describe pumpkins or any kind of matter. I heard some wonderful shares from you and your friends. So let's go through some of them right now, shall we? One of the most common ways that we describe pumpkins is by talking about their color. Now, many of you shared the color orange when we talked about pumpkins that you might have outside, or this pumpkin here. There are many shades of colors than just orange. This pumpkin is a little bit yellow. Maybe you've got a yellowish, orangish pumpkin at home. Maybe your pumpkin is green or some other color, right? Pumpkins do come in many different colors. The color of a pumpkin, or any matter for that matter, is a property of that pumpkin. Now we also have the pumpkin's texture. Texture is another word for how matter feels. When we think about how this pumpkin feels, many of you shared two words that are a little bit different from one another. Some of you shared that your pumpkins are smooth. And when we often feel a pumpkin with our hand, we might feel that it is very smooth. But if we get really close and feel small parts of it, we might realize it's not smooth like a mirror or other smooth objects in our home, right? It actually has some bumps to them, some ridges, right? So whether you use the word smooth or bumpy, both can apply to a pumpkin on its different parts. So texture is another way that we describe pumpkins and all kinds of matter. Matter is, of course, the word we use to describe the things that make up the world around us. Another word you might have used has to do with how flexible a pumpkin is, or whether or not it bends. Pumpkins do not bend well, right? We think of them as rigid. Rigid is a word that we use to describe objects that are not flexible. This pen, for example, is rigid. It is not very flexible. Whereas these pumpkin ears that Mrs. Pavlicek shared with me, right, they're a little more flexible. They can bend back and forth. Now, many of you shared that the pumpkin is round, and it is in fact round. Notice I didn't say circle. It's not a perfect circle, right? But it certainly has that round shape. It doesn't have many sharp corners to it. And some of you even shared a word that described the size of the pumpkin, right? Pumpkins come in large and small sizes and everything in between, right? Some of you might have thought of this pumpkin as a small pumpkin, and some of you might have described it as large. Scientists often measure objects with a ruler to measure the distance exactly, so they don't have to guess what the other person is thinking about how big or small the object is. They know the measurement. That is the exact distance or whatever it is they're measuring. In this case, when we measure size, we are probably measuring the length around the pumpkin or even across from the pumpkin. You often measure yourself by your height. So all of these words are great ways to describe pumpkins, but you notice that I've left one property blank today, and that's because I wanted to explore that property with you. And that property is the buoyancy of a pumpkin. Now, what does the word buoyancy mean? It's a super science-y word. Do you know what it means? That's right. We use the word buoyant or buoyancy to describe whether or not something floats or sinks. And there's no better way to determine the property of buoyancy for a pumpkin than to actually see if it floats or sinks. So it's time for our first demonstration of the day. Does a pumpkin float or sink? Like all investigations, we need the materials to complete the test, the investigation. I've got here a large tub of water to use to test the buoyancy of our pumpkin. I'm going to put on some special safety goggles. Not that I'm all that worried about water getting in my eyes. And what's that other tool that I need? Oh, I need a pumpkin. So here we go. Before I drop this pumpkin into the water here, I want you to make a prediction. What do you think is going to happen to this pumpkin when I drop it in the water? Do you think it will float or rise to the top of this water? Or do you think it will sink like a stone to the bottom of the container? Go ahead, think about it, share it with a grown-up or brother or sister beside you. All right, I hope you've made that prediction. When scientists make predictions, they often think about why. Why are they predicting what they are? Some of you might know something about the properties of a pumpkin's insides. Some of you might be thinking about the size of this pumpkin and whether or not something this big or small could float or sink. Right? Whatever it is, I don't think it was a wild guess. You were using your mind to think about why you chose what you did. That's the difference between a prediction and just a wild old guess. So here we go. Let's count down from 10 before I drop this in. Will you count down with me? Here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Whoa! Can you believe it? It looks like this pumpkin is floating. Let's add float to our table. The buoyancy of a pumpkin. Pumpkins float. Oh no. Looks like my marker got a little wet. Pumpkins float. That's to that. Amazing. Now, what's so fun about floating pumpkins is that this creates a whole sort of clever way that we can use pumpkins. Many of you shared wonderful pictures about how you use pumpkins in the fall. I have a short video of some folks who use pumpkins in a very unusual way because of their property of buoyancy, the fact that they are buoyant and float. Watch this video with me and see what you think about how these folks use pumpkins. Here we go. This is called the pumpkin regatta. Regatta is a big fancy word for boat race.
Hundreds lined the shore to take in this peculiar sight.
Pumpkins float, so why not?
About 40 brave paddlers boarded the giant pumpkins, alone and in pairs. For some, it all ended before it began.
It's pretty hard. They like to spin around a lot because they're not very seaworthy.
Their ships were extravagantly decorated, each participant dolled up to match.
I was up till 12 last night painting that, so measuring it and everything.
And as their works of art sailed the 20-minute journey across the lake, the fire department kept watch.
It's a lot harder than it looks. These pumpkins are about 600 pounds and pretty hard to steer.
Well, it's not a boat, I'll put it to you that way, but I mean, I'm so used to it now, I just consider it a boat.
This is the hardest thing I've done in a long time. Yeah, it was sore, but it was a lot of fun. I get to dress up, look like an idiot. It's all part of the fun, I guess.
A lot of fun, but clearly experience matters. Leo Swinimer has been paddling in the regatta since it began, took a few years off and decided to make a comeback this year. He took second place.
I always wanted to do it if I ever lived to be 80. So I'm 80 plus, so I wanted to do it, and I did it, and I enjoyed it.
For some, it was a fierce fight to the finish, but in the end, this mother-daughter team took home third place in their category.
What was it like doing it with your mom? Embarrassing.
Stephanie Van Kampen, CBC News, Windsor.
What did you think about that crazy regatta? Did you see how big those folks had grown their pumpkins? To grow a pumpkin that big, you need to know a lot about how pumpkins grow and what they need in order to grow larger and larger and larger. Fortunately for us, we have just such kinds of people right here in Burlington. I'd like to introduce to you 2 pumpkin engineers from the town of Burlington. Although they don't like to go by pumpkin engineers, they prefer the name gardeners. Ms. Heidi Mover and Mrs. Julia Eggleston, will you please join us now by unmuting your microphones and turning on your cameras? Mrs. Mover and Mrs. Eggleston are both members of the Burlington Gardening Club, and they're here to share with us a little bit about pumpkins and gardening. Thank you for joining us, ladies.
Thank you for having us.
Wonderful. I'd like to start with Heidi. Is Heidi okay, or do you prefer Mrs. Mover?
No, that's fine.
Okay, I'd like to start with Heidi. Heidi, I know you have done what scientists often do and go out and learn about the things that they are very curious about. What is it that you've learned about pumpkins over your time as a gardener that make pumpkins so fascinating to you?
Well, I found out that pumpkins are part of a very big family tree. They're one branch of a family tree called cucurbits, and that includes pumpkins and gourds and cucumbers and melons. In fact, if you wanted to save your seeds, you need to keep them separate, or you might get a mixture of something that you weren't expecting. So that can be a little unexpected. And I found that they come from North and South America, and that the pioneers didn't bring them over from wherever they came from when they came to settle America. The Native Americans have used them for hundreds of years, and they've found archaeological evidence that pumpkins have been grown on these 2 continents for thousands of years.
That is so cool to hear. Now, Miss Julia, I know that you have tried your hand at growing some giant pumpkins like the ones we saw in that crazy regatta, and that in some ways really fueled your interest in gardening. Would you care to share that story with us?
Well, I became interested in pumpkin growing when my children were little, because it was a lot easier to grow pumpkins than to buy a lot, because they never were happy with one pumpkin. So one year I was reading the book Farmer Boy by Laura Ingalls Wilder about her husband when he was a child in New York, and he grew a winning pumpkin for the state fair, and in the book she talks about how he grew it. So we got all excited to try it, and he used milk. Now, milk has a lot of minerals. It has calcium in it, which are important for pumpkins, and other minerals that help pumpkins. So we decided to try it. So in the book, he cuts a thin slit in the stem of the pumpkin and puts a cotton string in it, and then puts it in a bowl of milk. And the string leads the milk to the pumpkin and helps it to grow bigger. So we tried it, and unfortunately, it did not work for us. And we ended up with a pumpkin about this size. So not a very big pumpkin. I don't think we could have used it in the regatta. The next year we decided to grow our pumpkins without milk, and we grew pumpkins that were about an average size, about like this. So it was a little bit bigger, but I did some experimenting and some research, and I found out the reason our milk pumpkin didn't grow was because we probably made the slit too big and too deep, and we destroyed some of the little veins in there that needed to carry the milk to the pumpkin. So that was one thing. And also that probably didn't have quite enough sun, and you have to water any pumpkin you grow. You must water them faithfully because they require a lot of water. So when we were using the milk, we didn't put as much water in as we should have, because we thought the milk was water, but it really needs a lot of water. So if anyone wants to grow pumpkins, they need to remember to use a lot of water, and I would suggest instead of milk, you use a good fertilizer. But if you want to grow giant pumpkins, you have to have special seeds that come from a giant pumpkin, which I also did not know.
You know, I love so many different things you just shared, both about the science of pumpkins, but also how you used your knowledge about pumpkins and plants, the biggest possible pumpkin. I also love that even though it sounds like you didn't quite grow the pumpkin that you wanted to, you still kept on gardening. Is that true?
That is very true. Gardening is always luck. There's also a lot of science in it, but there's also Mother Nature, and you cannot train Mother Nature.
I love that. You know, I like to think of gardeners as agricultural engineers, because when I think about who an engineer is and what an engineer does, engineers use lessons from science, from investigations and learning about our world to try to make something that works. And in the case of gardeners, sometimes that's all about growing a whole lot of food or making your garden as beautiful as possible. Ms. Heidi, do you want to share a little bit about, I don't know, just what kind of science ideas you keep in mind when you grow a garden back home?
I have found from experience to be open for everything. If you like surprises, then being a gardener is a good way to get them. I found that it's kind of fun to not get the answer that you were expecting, and just kind of go with it and learn from your mistakes. And some mistakes turn out to be something that you want to happen, but you weren't expecting it. So.
Well, that is so true. As someone who has read and learned a lot about science and scientists, I know that some of the most important discoveries that have been made in our world have been made by accident. And so I love that you share how sometimes the most beautiful parts of your garden can really spring up unexpectedly. So Miss Heidi Mover and Miss Julia Eggleston, thank you so much for joining us today. And if you are interested in learning more about gardening in Burlington, just know that there is a whole community of Burlington gardeners that meet. Is it monthly, ladies? Is that right?
Yes, we meet monthly on the fourth Wednesday of the month.
That's right. And not only do they meet to share their wonderful tips and strategies and science behind their gardens, but they are also very generous and have always supported the Burlington Science Center growing contests, like the cucumber test challenge that we had this past summer. So thank you so much, ladies, for joining me today. It's been wonderful to hear about your love for science and gardening. And I hope you'll stick around for our remaining pumpkin demonstrations.
Absolutely.
Will you?
Absolutely. I'm excited to see it.
All right. Thanks so much. You can mute and turn off your cameras now. And we will move our attention back to one of Mr. Musselman's pumpkins. Now, normally this pumpkin science program is a part of a big show where we talk about matter with our second graders. And this year is no different. We're still learning about matter. And one of the things that we think about when we think about matter is we think about changes to matter. So there are some changes that can be reversed. To reverse is to undo or go backwards. Now, many of you shared pictures of you with pumpkins that you changed. One such kind of pumpkin that I often see on doorstops as I travel around Burlington, sharing science at schools and with our community, is of course this kind of change, right? This is of course a model jack-o'-lantern. Now, what's interesting about my jack-o'-lantern here is I've made some changes to this pumpkin. Right? One of the most important changes that I've made to this pumpkin is that I've done some cutting, right? I've gone in and cut out pieces of this pumpkin that can be removed. Right? I've changed this pumpkin's shape, and in some cases I've made even smaller pieces of that pumpkin from the much larger pumpkin matter. Right? This is an example of a change that can be reversed. Right? Because as easily as I cut out that piece of jack-o'-lantern, I can also put it right back where it was. I have not changed the fact that this pumpkin is still made of pumpkin matter. It's not new matter. It's not jack-o'-lantern matter or any other kind of matter. It's still pumpkin. We've just changed some of its properties. We've changed its shape, or in this case, we've changed its color. Right? But there are some changes that cannot be reversed in our world. Once we change that matter, we cannot turn it back, right? We cannot reverse that change. And for my final pumpkin demonstration today, I'm going to share you one such matter change. It's called a chemical reaction. A chemical reaction is when we take two kinds of matter or more and mix them together and create a brand new kind of matter. And the matter I'm going to make with you today is the type of matter I like to call pumpkin puke. Are you ready for pumpkin puke? The first thing I need to do is I need to remove some of the parts of this pumpkin. So I'm going to take the top off here. I've already gutted this pumpkin and removed the seeds and fibers and some of the pulp that is inside a pumpkin. Right? I've also already cut out these eyes, nose, and mouth. Because after all, that pumpkin puke has to go somewhere. Now, pumpkin puke is made of a mixture of several different liquids. It's made of some water and dish soap, right? And one type of chemical that we actually get from a chemistry store, right, for science, right, that's been mixed in here. It's the special ingredient, right? Now, that special ingredient is going to react with this clear liquid I have right here. This is not water. It would not be safe to drink. This is hydrogen peroxide. You might have some hydrogen peroxide at home. It's a useful kind of liquid that can help us clean cuts and scratches on our body so that germs don't get inside. This hydrogen peroxide is much more concentrated than the type of hydrogen peroxide you probably have at home. That means there's more of it mixed in with water than the hydrogen peroxide you have at home. Yours is what they call a little more diluted. But when we mix these two chemicals together in our pumpkin, they are going to create a whole lot of matter in the form of a gas. Gas is an air that we're going to catch with the bubbles inside our container. Now, when this reaction occurs, it also creates a whole lot of heat. And we will see that heat through steam that will come out and rise through some of the pumpkin. Are you ready for pumpkin puke? I know I am. I'm going to put on my goggles once more because this type of chemical reaction I certainly do not want to get in my eyes. So here we go. I'm going to bring this down. It's been wonderful sharing pumpkin science with you today. Boys and girls, I want to remind you that this video has been recorded and will be put on YouTube later, so that if you need to go to specials now, you will be able to see this and repeat and watch this as many times. You can also reach out to me, Mr. Musselman, at my email, musselman@bpsk12.org, to tell me what you think about this pumpkin puke. Are you ready? Here we go. 3, 2, 1. Uh-oh. Uh-oh. Oh. 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 Oh! Oh! That is some gas. Woo! Some heat. I can feel it. Smells like my dishwasher. Boys and girls, have a great day. I'm going to put on that presentation one more time, and then I'll close the stream. Be well, boys and girls, and I will see you again soon.